These are the notes for 3.1. We have just a couple of definitions to go over before I show you how to actually solve quadratic equations. So with quadratic equations, we actually have several different methods. With 3.1, I'm going to show you 3 of them, and we will get to other ones down the road. But okay, so 3.1. An x-intercept is where the function crosses the x-axis. Okay, basically, and that means it's when y equals 0. Okay, the x-axis is when y is 0. So with quadratics, we have root of equation. Actually, with polynomials, we have roots of an equation, and that is just the solution of the equation. And since quadratics are to the second degree, that power that's squared means it's to the second degree, there's always going to be 2 roots. And the zeros are the x values, so an x value when y equals 0. So intercepts and zeros should look similar. If y is 0, solving an equation would be a solution, so a root. If you notice, all of these things, they all are the same thing. It's us looking for the solution to the function. So if we have an x-intercept, it's the same thing as saying it's the roots of the function, which is the same thing as saying the solutions of the function and the zeros of the function, okay? And with quadratics, there is always 2. So in 3.1, you're going to learn how to do this by graphing, and we are going to use our graphing calculator. No need to graph them. You can graph them on a graph. That was chapter 2, so you should know how to do that. But sometimes it's not a clear point, and the calculator will give you the exact point of that x-intercept. We're going to solve by square roots, and you're going to do this when you have something being squared and a constant. There is no just x value in it, okay? That's when you'll want to use square roots. And then by factoring, okay? And with factoring, not everything is factorable, so you will want to, I'm going to show you how to do factoring, but when it's pick your own method, just remember it won't always work. I think in 3.1 it does, but down the road it won't. So I'm going to eventually show you a method. Obviously graphing would always work. And then in 3.4 you're going to learn a method that always works. So the zero product property just says if A and B are multiplied together and equal 0, then A has to be 0 or B has to be 0. So that's how you find your solutions or your roots or your zeros. It's you set each thing equal to 0 and you get your answer. And I'll show that more when I show you how to do the factoring. So kind of ignore these graphs. Although if we were to graph this one, you know, it'd be, if I counted by 3, it'd be like right here, something like that. Or not counted by 3, but counted by 2s. But I'm going to show you how to do it using your calculator. Okay, so I got to turn the calculator on. Now, this is equal to 0. It has to be equal to 0 before you can put it in your calculator, okay? And 0 is the same thing as saying that's the y. We're saying y equals 0. So in the calculator, I'm going to push the y equals button. Whoops, clear that out, sorry. And I'm going to enter in this equation. I have x squared minus 11x plus 24. And then I'm going to graph it. Okay, it takes some time here. There it is. And you can visibly see that, oh, it goes exactly through 3 and 8. It won't always go exactly. So this is how you have it calculate what those zeros are. Okay, remember you want the zeros when the y is 0. That's the zeros of the equation. So if I tell it to calculate, second, you see this trace button? Above it, it says calc. It will calculate the zeros for me. So I'm going to push 2. And this tells me to find a left boundary. Well, I'm trying to find this 0 right here. Find where it crosses the x-axis. So I'm going to go on my graph left than it. Now it tells me I'm already at x is 0, which is way up above my graph. So I'm actually going to keep scrolling right until I actually see, there it is, see a little bleeping symbol there, crosshairs. Okay, now this is the 0 I'm trying to find, and that is left of it, so it can be anywhere. It could be here, it could be here, it doesn't matter. I'm just going to push enter. Okay, then it says find the right bound. So I'm going to go past this the intercept somewhere and push enter again, and it says make a guess. Well, I don't need to make a guess. I'm just going to push enter. And it tells me when y is 0, x is 3. So in this case, I'm going to get an x equals 3. And I'm just writing it on my graph. And now I need this other one, because remember, there's always 2 answers. So I'm going to have it calculate again. I want the zeros. Now this left bound, I have to make sure I'm not left of this intercept. So I have to go between my 2 intercepts. It doesn't matter how far, because I'm left of this one but right of that one. And then it wants a right bound, and I just made it just right of it. Enter, push enter as your guess, and it tells me when y is 0, x is 8. So x equaling 8 is my second one. Okay, so there are my 2 answers, my 2 solutions to that equation. Okay, so I'm going to switch these here. Okay, there we go. Hopefully you can still see what you need to on the calculator. All right, now this problem here is not equal to 0. So I need to make it equal to 0. And I'm going to do that by subtracting 13 to both sides. And I get 0 equals x squared minus 25. Okay, now this is one of them we could solve by square roots, but in this case we're not going to. Oh, I forgot. It's negative x squared. There we go. Negative x squared. So if I go to y equals, I'm going to clear out this one. I'm going to push negative. Make sure to push, let me zoom out just slightly. Oops, wrong way. See the negative button down here? Don't push minus. You have to push negative x squared, then you push minus 25. So if you notice there's a difference between the negative and the minus in size. If you push in the wrong thing, it'll just give you an error when you try to graph it. And I graph this one, and nothing is showing up. So you can change your window, or we can just zoom. I'm going to zoom out because I don't see anything. So I'm going to push zoom, and I push 3. It didn't zoom yet until I push enter. And if you just keep pushing enter, it's going to make it keep going. Well, in this case, I'm not going to keep going. 1 enter was enough. I can now see my graph. And here's the thing. Does it ever cross the x-axis? Remember, my solutions are those x-intercepts. Okay, it's got to cross this axis at some point, at least one. And this one doesn't. Its vertex is below the axis, and then my graph goes down. So this one would actually have no solution, no real solution. When we get to 3.2, you're going to see how this one would actually, so you need to put in the word real, sorry. Because you will learn in 3.2 that it actually does have a solution. It's just not a real number. It's an imaginary number. But we haven't covered that yet. That'll be next chapter. Or next unit, or section, sorry. Now, again right here, I need it equal to 0. And it doesn't matter if you move the 12 x squared to the left or to the right by subtracting it or moving everything over here. I personally just get in the habit of leaving my x squared positive. So I'm going to move everything to that side. So 12x squared minus 5x minus 2 now equals 0. And I'm going to enter that equation in. 12x squared minus 5x minus 2, and I push graph. And it'll eventually graph. Now see, it's real tight. I can't really see anything, so I'm going to zoom back in. So you can either change it at windows, and we usually leave the windows set at, see, negative 40. We usually leave it at negative 10 and 10. The y is at negative 10, 10. Or you can just go zoom, and we want to zoom back in. So I'm going to push 2 and then enter. And now I'm back where my presets started me. All right, so now I can see it crosses that axis. So I'm going to have it calculate my 0. I need to go left bound of the first one. So that's to the left of where it crosses. Now I need to go right bound, but don't go past your other one, and then push enter. And this tells me when y is 0, I get a negative 0.25. So you could say x equals negative 0.25, or you could say negative 1/4. Oops, you can't see that. Those are the same thing. Okay. Now I need to calculate the other one. So second calc, zeros. Now for the left boundary, I need to be between the two zeros. The right boundary, I need to go past it. Enter again. When y is 0, this gives me 0.6 repeating. That is 2/3. Okay? So I have a negative 1/4 and a 2/3.